All right, everybody. Everybody can hear me just fine? Awesome. My name is Piyali Kamra. I am the enterprise architect for retirement and global solutions in Morningstar. What I'm going to talk today about is I'm going to take a case study as to how we went about building a conversational AI ecosystem on AWS. The agenda for today is I'm going to provide a brief introduction as to what the case study was, what was really the business problem that we tried to solve. I'll go over a flow chart as to how we went about solving that particular business problem. What did we do? How did we build it? I'm going to talk a little bit about serializing a machine learning model. What I'm going to talk about is a little bit about the various steps that are involved in the process of creating a machine learning model. So we'll talk about the importance of data collection, preparation, and validation. In our use case, we basically used a supervised machine learning algorithm. What did we do? How did we go about choosing our algorithm? What did we do to separate our data into test and training sets? How did we go about calculating the prediction accuracy percentages? And then the final stage that was serializing a model. We created a .pickle file. So I'll go about the process, like I'll show a little bit of code so that, if people want to create their own models, or what I commonly call as BYOM, that is bring your own model on AWS SageMaker, then what are the various steps involved in it. The next step that we'll do after we serialize a model is we will see how do we bundle this model, because you can't just be running the model on your local workstation, but what you need to do is basically you need to bundle this up and serve this up on AWS. So we'll see what we did for that. We basically will see the creation, what goes into creating a very lightweight microservice framework called as Flask. We put the brains into it, that is the model that we created, and then we finally packaged it into a Docker container. I'll speak a little bit about when you do BYOM on AWS SageMaker, there are certain things that you need to be careful about so that you know for sure that your model will work properly on AWS SageMaker. And then we'll see a small demo about how we went about locally testing this Docker image, because then we know for sure that the image that we have created will work well on AWS SageMaker. And then we'll go over the various steps involved in deployment preparation for AWS. So frankly speaking, once you've created your model, you're happy with the prediction percentages, there are essentially two stages that you need to do before you can actually start productionizing this model on AWS SageMaker. The first stage is uploading the Docker image onto ECR, and the second stage is basically you compress that model into a tar.gz file and upload it on S3. Then we'll go over, I'll just show in the demo like how we went about creating the model configuration, the endpoint configuration, and the endpoint. Finally, it's a recommended way in the Amazon documentation, that is to create a Lambda function which will point to this SageMaker endpoint and expose this Lambda function via API gateway. And then we'll see how we use the Chalice tool. Again, as per Amazon's documentation, this is a very wonderful tool. I'll show you, like we just wrote 30 lines of code and we were able to basically deploy a Lambda function and create an API gateway endpoint for our SageMaker model. We will just go over and test a few test cases over this model and see how it returns predictions. And finally, we are going to integrate that with a fronting chatbot. So this is like what the use case that we really tried to solve was we get a lot of customer service questions. Our customers ask us questions related to what are the funds which are going in my 401k plan? How do you create my portfolio? Things like that. And these questions, so what we started doing is we started analyzing the Salesforce and the Jira tickets. The first thing that we wanted to do was basically we wanted to classify what are the sentiment of the customers, what kind of questions are they asking us, how do we classify the category of these questions. And when we started doing this exercise, we realized that we realized that there were two flows. One was how can we proactively intervene in certain scenarios and prevent the customers from churning out of our system. So when we realize that the sentiment of the question asked by the customer is that they want to churn out of the system, if we are able to intervene over there and call a downstream, if our model can actually predict that the question asked is related to, say, for example, closing the account, we can proactively intervene and create a downstream service which will then alert our advisors to talk to the customer and make sure that the customer doesn't churn out of the system. And the second thing was, there are certain questions that can be easily resolved by just directing the customer to an FAQ page or a video or some content like that, instead of having those questions come to our downstream customer service associates. So that's what we saw, we wanted to proactively intervene. We wanted that user engagement increase, and we also realized that in this customer service world, instant gratification is very necessary. So what is the goal of today's session? So what I'm going to try to do is, I'll just go over the initial steps over how we've basically created our machine learning model for basically doing the sentiment analysis around the questions. And I won't delve too much deep into what goes on into writing an algorithm, but basically I'll show how you can combine various tools and technologies in the AWS landscape to basically maybe create your own machine learning model and have a chatbot in front of it, or have any downstream services that interface with that machine learning model. So in the end, what you'll see is basically a chatbot that we integrated with a sample static website, and where you can actually write your questions. And this chatbot under the hood is going to interface with the machine learning model that we create, get the predictions back, and serve up content to the customer based on that. This was basically a workflow that we initially came up with. What's the very first thing that we do? We clean up our data. So as I say that, it's garbage in, garbage out. So especially when you're dealing with machine learning models and supervised machine learning algorithms, you have to be very sure that the data that you use has to be cleaned up properly. We spent a lot of time in cleaning up the data, validating our data, iterations over iterations. We had to make sure that in order to get the correct classification, when we break up our test data into training and test sets, we had to make sure that the training set actually has a good percentage of data that falls into each of these buckets. We had to clean up the HTML tags and unnecessary words like good morning, good evening, things that really do not affect the prediction in any way. So that was really the first thing, and I'm going to go through the process of I'll show you what a sample data that we used from our Salesforce system. Then we ran through different algorithms. So initially we took a number of classifiers and different kinds of algorithms, and we divided our data into test and training and test set, and then we started getting prediction analysis. And after that, at the end, we were kind of comfortable with two algorithms when we got about 85 to 90% prediction accuracy, and then we went with that particular model. So that's where we did the stage number 3 and 4, that is run tests to make sure that the classifications are accurate, and then measure the accuracy of the model. And then we will go over in the demo as to what goes on, what are the steps involved in exposing this model as a real-time API. A few things that I covered was how do you bundle up the model into a microservice framework like Flask, how do you create your Docker container, so we will go over that as well. And then testing the API, obviously, now we had two paths that were available to us. Either we can hook up this API with our Salesforce or the Jira ticketing system so that we can get real-time predictions. And then based on the category, we would have downstream services which would decide what to exactly do to engage with the customer. And the second path that we had, that we came up with, is integrating this particular API with a natural language processing chatbot. And this is an example on the right-hand side of the various classification models that we saw as we analyzed our data, like fees, investment advice, closing up the account, sign up, and functionality. And closing up the account was the main use case that we started kind of dealing with, so that we could reduce the churn rate of the customers from our system. Now, I'll have a short demo. I have like 3 demos over here today. So the first step, I'm just going to briefly go through. I'm going to breeze through actually the data preparation part, the model creation, the prediction analysis, and serializing the model part. And then after that, in the second and third demos, I'm basically going to show you what are the steps that are involved in uploading this model onto AWS and basically integrating that with the chatbot. Okay. All right. So the very first thing that we did is basically, so we used Python for basically creating our machine learning models. Now, even before that, this was like, we took a dump of thousands and thousands of Salesforce records that we got, the actual customer service calls. And then we went across, we actually, as I said, we did this process of data cleaning and data validation. We went through this entire data set. And then we cleaned up the data, and we, in supervised machine learning algorithm, it's very necessary to basically tag your data, classify the data properly. Once we did this exercise, we basically fed this data into the Python code that we had. Here is just a small sample of what we did initially. We tried using multiple classification algorithms. We use natural language text kit. We also use Python's sklearn library. What basically goes on is first you read your entire data set using the pandas data frame, and then you already have decided based on when you were tagging your data, what are the different classification categories. And then what we do is we do some cleanup on the data as needed. It may be needed or may not be needed. And then we divide our data basically into 70-30. 70% of the data is used for training the model, and on the remaining 30% of the data, we really get the prediction analysis. What we did is then we create basically a machine learning algorithm pipeline. There are basically 3 things that we used in that. This is text. We need to convert it into some kind of a vector format of zeros and ones. So we use some kind of a vectorizer. Then what we did is we used a TF-IDF transformer. This is basically called as a text frequency inverse document frequency transformer. Why we use this is we found that there are certain words like he, she, is, the, a, the words like this which are probably present in almost each and every document. But these words really do not affect the prediction of the document in any way. They do not affect the sentiment of the document in any way. So that's why we used a text frequency inverse document frequency transformer. So more the number of times that that word occurs in the documents, it basically you give it a very low weightage, and that nullifies the effect of that particular word in the document. And then we use some kind of a classification algorithm. So we tried out with various classification algorithms like knife-based classifier, and then we predicted that. After that, we used the SGD classifier with some hyperparameters as well. We went ahead and then used logistic regression, so on and so forth. We also used Google's word2vec. We found that to be a very nice library for sentiment analysis. We tried using, in the very end, we also tried using I think TensorFlow and Keras, and we did not get a very good prediction percentage. So here is just like briefly, I can show you like when we tried using knife-based, we got a prediction percentage of 69%. And then when we tried to use SGD classifier, we got something like 75%. And then after that, when we tried, and we did this over iterations and iterations. So this is not like the very first time you try to import the data and you're going to get a good accuracy percentage. We started off somewhere around 40% and went all the way till 85%. So here, logistic regression, you can see it's like 80%. So once we did this, we basically came up with 2 models that we really liked, a logistic regression model and the word2vec model. After that, what we did is we basically separated out the training and the test code into two. Once we were satisfied with the model, we created a separate training code base where the last line, if you see over here, is we are basically dumping it and creating a serialized version of the model called as a Pickle File. This is what I referenced in the second slide, where I showed that when you serialize your model, basically what you do is you create a .pickle file. Once we created a .pickle file, the next stage is basically what do you do with this .pickle file now? This .pickle file will need to be, in order to productionize this, we need to be able to use some kind of a microservice framework. So what we did is, we actually went about and used Flask microservice framework. Now, so here if you see, this is a short code that we wrote for basically using the Flask microservice framework. As you see, like when this whole thing, that is the Pickle file and the microservice framework is actually bundled inside the Docker container, and if you want to bring your own model to AWS SageMaker, it is necessary that the model should be present in OPT-ML model path. Otherwise, it doesn't work. So that was one of the things we had to make sure that when we are reading the model inside the Flask microservice framework, you have to read it from this path. For local testing, what we did is, and I'll show this, we created a Dockerfile. When we ran the Dockerfile in local, we basically did a volume mapping. So we did a volume mapping of local test directory, model to OPT-ML, and that is how we tested the Docker container in our local. So if you see in the Flask microservice framework basically just provides a route so that you can call real-time predictions on this model. The first thing we did in that was basically we did a joblet.load, and we loaded that particular Pickle file. And then if you see, this is the most important thing, we defined a route through which this model can accept the text in the JSON format. And finally, what it will do is it will predict. So over here, we did a model.predict. And in the end, we return the response back to the client. So now that we have a Flask microservice framework which is loading this model, we went ahead and we created a Dockerfile. What I'll show is, I'll just show a small thing, that is, I have already created a Dockerfile on my local. I've created a shell script over here to basically do the volume mapping between the test directory with the OPT-ML. And that way, this model, once this model is active in the local environment, I should be able to send requests to it, and it should be able to send real-time predictions back. So let me go and try to do that. Right. So once I'm over here, I can actually go and just run. I just have a shell script created over here, which I showed you. I'm just running the Dockerfile inside of it. Now, so the Flask microservice server is up and running, and let's try to just do a quick. So this was one of the steps. So it's very necessary to do some local testing, otherwise you won't be guaranteed that, and to test out the volume mapping, otherwise you won't be guaranteed that this model will work properly when it is deployed on AWS SageMaker. So this is actually a text that a customer sent us. He basically wanted to know, how do you decide the star ratings of the various funds that you put in my portfolio? And this is something that we felt these kind of questions can be handled via giving a FAQ, surfacing an FAQ document to the customer if we had a chatbot integrated with our website. So what our plan was, if we have a model which can take this text data in and can send the prediction out, it would be really good. So as you see, this model sent back the prediction as investment advice. So you see this over here as investment advice. So this kind of finishes at least how you can test out this model in your local environment and be sure that it is going to work on AWS SageMaker. Now comes the fun part of it. I've tested it locally. What is the next step that I need to do? Before we go on to that, so this was just like, I just had a slide over here to show like, the various classification percentages that we got with the various algorithms. And this was basically a text analysis or a sentiment analysis use case. Now is the fun part. So how do you productionize this model as an API? Again, we will go through a demo, but just to run through the various stages. We saved the model. We create a microservice framework, we went through that part. We build the Docker container, we did that. We test the Docker container locally, we did that. Next is, we deploy the Docker image. We will also upload the model artifacts to S3. So as I said, in order to productionize your model, there are really two basic steps that you need to do. The first one is you deploy this Docker image, which has the bundled brain plus the Flask microservice framework. And the second thing is the model, the Pickle file that we created, we are basically going to compress it as a tar.gz file and upload it to an S3 bucket. And after that, there are three things that we will be doing on AWS SageMaker. A model, we'll have to set up certain configuration things for the model, an endpoint configuration, an endpoint, and finally, we will create the Lambda function and expose the Lambda function, which will integrate with this AWS SageMaker endpoint and expose it via the API Gateway Endpoint. And then we'll test it via the Postman and integrate it with our fronting chatbot. So now, after we do that, so I have already created a Docker file over here. And then I also created a build plus push shell script. What this has is really, if we go back to the AWS console, so let's see what we need to do to basically upload that model into Docker. So when you go into your ECR registry and just click on the view push commands, it basically writes everything that you kind of need to script if you want to push that particular Docker image into ECR. So all that this shell script does is basically, that's what it does, in other words. All those commands are basically in the shell script. I just ran that beforehand so that the image is present in Docker registry. This image has the Flask as well as the Flask microservice framework. The next thing that we did was the model that we created over here, we created a tar.gz file and we uploaded that to S3 bucket. So over here, now for this session, I had already uploaded that file into the S3 bucket. I'll just quickly show logistic preparation. Okay. So here I already have the tar.gz file, and if I download it, you will see that the only thing it has, like if I download it, you'll see is that it just has the pickle file. That's all that it has. This is just the format in which AWS SageMaker really needs it for all BYOM models. Next, once we have done these two things, we are basically now ready to create it in AWS SageMaker. So as we go to SageMaker, on the left-hand side, you'll basically see that there are three things: models, endpoint configuration, and endpoints. We'll go through these three things. Now, in order to create your model, and I had created a model over here, all that you need to do is basically you need to give it a reference of the path of the Docker image, and you need to give it the path of the S3 bucket. So I could just create another model, but yeah. So all that you need is you just give it like a model name, and you can just give your Docker path, which is this. This is the path. and just the S3 bucket. And super easy. And so that's it. That's all you need to do to create a model. I had already created a model, so I'm just going to go ahead and delete this for now. The next thing that you do is then you create an endpoint configuration. Again, the endpoint configuration basically refers to the model that you just created. So in this case, as you see over here, I just had to create an endpoint configuration and refer it to this particular model. The very last thing that you do is you create an endpoint. Now, I had already, again, created an endpoint. This is the name that you will be basically using if you are creating a Lambda function using the Chalice framework. So once this endpoint internally is again referring to just the endpoint configuration that we created before it. It takes a couple of minutes, like 10 to 15 minutes, for this endpoint to become active. Once it's active, the next step that we did, and this is again an AWS documentation recommended way, was to create a Lambda function, because you can use this endpoint directly in your code, but it becomes a little bit clunky. So the recommended way, as per AWS, is to basically use the Chalice framework. So we went through these steps that we did right now. We compressed the model, we uploaded it to S3, we uploaded the Docker image, we created the three things, the model, configuration, and the endpoint on SageMaker. So one thing that we have to also do is, after we have uploaded this, we have created the SageMaker endpoint, let's quickly go through what it means to use the Chalice framework and create the Lambda function and the API Gateway Endpoint. So here, as you can see, as I was telling you, if you want to create a Lambda function and an API Gateway Endpoint, the most important thing is just to remember that endpoint name, because that is what you'll refer. And as you see over here, it's just 40 lines of code to create the Lambda function and the API Gateway Endpoint. And if we are and this is for real-time predictions. This is not for batch mode. In batch mode, if we want to return predictions and do some batch mode analysis, there is batch transform jobs. Right now, we are only going to cover the use case of a real-time, what do we do when we want to send back real-time predictions. So as you see, with 40 lines of code, we can actually create an endpoint. And what happens is, when we go to this Chalice directory, all we need to do is a Chalice deploy command, and it is actually going to create, like, it takes maybe 2 or 3 minutes. It basically creates the Lambda function and will also give you the endpoint URL of the API gateway via which, and you can take that API gateway endpoint, and then as you see over here, this is, so it kind of very quick. So this is the endpoint that we really take, and then we can use this in Postman and just test it. And this is the same text, I'm trying to send it the same text that I used previously with the local endpoint. And the expectation is that it will send me the prediction back. So the model sends you back the prediction, that is, it's related to investment advice. Let's try to take something else. So for example, I'm losing money, I want to close my account. These are the kind of customers that you can prevent churning out of your system if you proactively take care of their concerns. So it's the model predicted that this question is related to closing the account. What will it cost me? Fees. What are the charges? What is the cost? Something like that. What is the cost? Fees. So that is how, so we know that, okay, the model is up and running. There is a Lambda function integrating with that AWS SageMaker endpoint, and in front of that, there is an API gateway. And as I mentioned, we have to make sure that the predictions come back in 29 seconds because that's the API gateway timeout. Now, the last stage is basically, so we basically, in the beginning, I showed you that there were two flows. One was we can integrate with downstream services, and the other was how do we front it with the chatbot. Now, once all this is ready, you can use we use the natural language processing chatbot libraries, open source libraries, to basically create your chatbot and then integrate it with whatever channel you want. It could be a static website, it could be Twitter, Facebook, whatever. So these chatbots, there are certain chatbots integrate with certain channels better as compared to some other channels. So as per your convenience, you can choose an open source library of any kind of chatbot. So here now I just have a chatbot that's running over here. Let me just try to start that. And then I have a chatbot which is basically integrated with a static website. And I'm going to try to send it the same question. That is where the customer wants to know how do we basically rate the funds. And here the chatbot returns back. So not the chatbot, the model behind the scenes returns back the prediction as investment advice. And then the natural language processing chatbot basically shows content based on the classification that has been returned by the model. So in this case, the chatbot is showing the content based on investment methodology. And then you can show some content based on that. Now, for example, if I kind of just write, here I want to close my account. Then it shows me, okay, for help with opting out of managed accounts, I can point you to the following resources. And then there is a contact me form for opt out or advantages of staying enrolled. And like, if you click on that, like contact me form, you can just show a link and then that can further open up a FAQ page or a form for the customer. So going back to our slides right now, So that was basically, so that's the end of my presentation basically. So we integrated with the chatbot. So now we have seen the whole ecosystem of, how do you basically start off with creating your own model, how do you serialize the model, then how do you bundle it up with a microservice framework, bundle it up in a Docker container, push it to S3, then compress your model file, create your Docker container, push it to ECR, and then finally what all steps do you take on AWS SageMaker, and then depending on your use case, you can either integrate it with other backing services, or you can integrate it with the natural language processing chatbot as we did. That's about it. Questions? Yeah. No, we have to do that exercise of cleaning up the data, tagging the data, coming up with the classifications. Like we worked with our research team to basically come up with the different classification categories. Yeah, well, for our use case, supervised learning was best suited. But yeah, sure. I mean, we work mostly with supervised learning for this particular use case. And what I have found is there is no one size fits all with respect to machine learning. It's all based on your use case. For our use case, since it was sentiment analysis based classification, it was basically a classification use case. And kind of classification use cases fit very well in supervised machine learning paradigm. That's what we had used. Yeah. Yes, we did. We did lemmatization stemming. So within our code, like as a part, we use the NLTK library, and we use that to actually, so like opt out, opting out, opted out. No matter what you put, it will tell you you're trying to close your account. So we did do stemming and lemmatization. In fact, I don't remember clearly, but we used one of the either. Because when we, I believe when we tried to use stemming, or maybe lemmatization, one started giving us very bad results. So we were not able to use both of them. We used just one of them. 85%, uh, sorry, just once. We basically used just the percentage, like the, whatever was the prediction percentage that we got, that was what we used. Yeah. This is in the beta phase, like we are testing with our customers and the research people. Um, yeah. So we spent, I would say, about 3.5 to 4 months. Yeah, 3.5 to 4 months. We spent a great deal of our time really in basically data validation cleaning. That was really our, that took a lot of our time. Like 4 to 5 weeks really went into that. Uh, and then once we knew, like we used, then we had a couple of algorithms that, like we kind of knew these would probably help us, so we went through that. We had to do a lot of iterations because initially the predictions were very bad, and we had not even used lemmatization or stemming in the very first iteration. Then we started introducing lemmatization stemming. Once you start introducing that, you start seeing the algorithm which was previously working very well starts behaving very badly, and something else starts working fine. It's basically, yeah, like, and the more data you feed into your system, the better it is. It's always getting right data, correct data, data that makes sense, and then cleaning up that data. That really took a lot of our time. Once we were able to perfect that stage, everything else was like kind of fell in place. Like we learned from our mistakes. But data cleaning, removing the HTML tags, things that don't make sense, that was very important in the training phase of the model. How do you address misspelling? We have used, so Google's word to vec, if you use that particular library, it kind of takes care of certain misspellings as well. And NLTK also, so it takes care of certain misspellings as well. We found that out, like, so instead of saying like, uh, in how do you, investment, if you write investment without a T, you would still get back your prediction as investment. So there are these libraries, the open source libraries, which help you take care of those things. To a certain degree, we took care of that by using the Google's word to vec, doc to vec, and the NLTK library to some extent. Do we have time? So in the natural language processing, like the fronting chatbot, when you cannot understand certain things, there is always certain default actions that you can take. And then what happens is, another thing we need to remember, which I didn't cover over here, is your models have to be refreshed. There is a batch, you need to have a batch processing, a refresh process, what we call as, right? You need to have that refresh process, and that needs to run maybe once a week, once every month, maybe once every 2 days, whatever. You have to come up with the frequency, you have to try and test. So that will then update your models, right? So that you can, like, because the questions that the customers will ask will keep changing over time. So we can't say like we've created a model and that's it, that's in production. Our plan is, and right now we are trying out the batch refresh process as well. We'll be learning more from that, and we'll go on. But I think like that's usually what is done. You need to have a refresh process for your models. Otherwise, they are going to get stale over time. All right, I'll be there if you all have any more questions. Oh, okay. So basically it's a managed service, right? Like you get the benefit of a managed service, handling as many, like you don't have to worry about your load, how many people are going to concurrently call it. You don't have to worry about all those things. It will handle all those things for you. And then finally down the line, we'll be having a CI/CD pipeline and everything, which will finally deploy this to SageMaker. It becomes a lot more easy for us. Basically, so that we don't have to manage the infrastructure, because if you try to run like a machine learning model on, if you're trying to do the training on your machine, you will just start seeing, like, as it tries to train, as the algorithm tries to train over the test data set, it starts using a lot of, like, you will just start seeing yours, it starts using a lot of your CPU cycles. So this is completely managed, like SageMaker will manage the kind of instances, the kind of machine that you need. It will manage for you under the hood. It was just easier for us to offload all that to AWS SageMaker. All right? Okay, all right. I'll talk to you there, John. All right, thank you.